And we are live. Ladies and gentlemen, a very good afternoon and a very, very warm welcome to the PROSTEP Insight Days 2023. We're very, very happy to have you, our international guests, on board right now in our stream, because we're going to give you a summary over what we've been doing today during the other sessions that were held in German, but that will also be translated into English and made available to you online over the next couple of days so that you can also go into detail. But right now, we thought a 90-minute summary would be the best thing for you in order to be up to date with our content. And that session is titled Designing for Consistency, Strategies for Achieving Digital Continuity Across the Digital Thread. At the end of this session, we're going to have a Q&A part. So if there's any questions on your mind, don't hesitate to write them down in the bottom right box there on your screen. They will be passed on to me via iPad, and then I can pass them on to our speakers so that we can make sure that all your questions will be answered already today. So our speaker for tonight is going to be the Director for Technical Pre-Sales at PROSTEP. His name is Brian.schouten. He's American, so he is very well suited to be informing you. But before he comes up, we actually have a few greeting words by board member Carsten Theis. Please enjoy.
Yeah, happy to see you this afternoon, and a warm welcome from my side to our international guests. During the last years, our customer base has grown dramatically. So especially our subsidiary PROSTEP Inc., where Brian is from, has been super successful, but we also found customers in China, Australia, South America, and all over the world. So we invested a lot in our products to support international companies, like multi-language support, but we also invested in our service and delivery team. So today I'm happy to say that we are absolutely able to support worldwide delivery, worldwide support. We have a new support portal up and running. And yeah, we are committed to your success. And we'll go on investing in our international strategy. And I think all the details will be shown by Brian to you. Brian, please.
Well, thank you, Carsten. Yeah, and Brian.schouten again from Detroit, Michigan, and that's where our local office is. And I'd like to go through the OpenCLM and do a recap, really, of all the German presentations that were done today. We have a nice story, including the Mars rover and the PROSTEP products in conjunction with that story with the Mars rover. So starting, we're going to take a look at a little bit of the challenges that we're going to see within OpenCLM, or the product complexity and mastering product complexity. That starts really with digital engineering challenges that we have, including the V model of systems engineering, starting really at the top and going down vertically, trying to match the requirements that you might see when a product to the functional and logical configuration, to the engineering data that you're going to generate, for the product engineering, the analysis and simulation, as well as the electronics and mechanical data and CAD data that you're going to have there. Trying to bring those all together. That might span the product lifecycle, so from concept, through the initial definitions all the way to obsolescence. And that could also span kind of the concurrent engineering definition, so across different domains, trying to bring that mechanical data together with the data in electrical or software data, and propose that all together as part of a chain, I guess, within the digital thread. That data, once it's established as a digital thread, can then be used, for things like, reporting and documentation and validation and verification. So across the V model, bringing that data back for the V&V practices. So across, this digital thread, we want to also utilize first our introduction to our first product, OpenCLM, bringing data together into the product lifecycle so that you can then manage data within the different environments that you already today have, environments that might have requirements or functional logical design, mechanical like CAD, electrical. These different domains have different systems that might master that data. And we want to be able to have a place with OpenCLM that you can bring that tapestry together effectively. So you want to be able to link data from those domains, but not rip and replace that system that's available today for doing that. And OpenCLM is a product that specializes in doing that and kind of sitting on top of your existing systems, relating data, pulling in data from all the different domains, and then enabling you to then make decisions on that data. It could be decisions forward in the kind of the process that you follow. Maybe you have a specific program and product lifecycle process that you're going through. You can create a template to make sure that each of those tasks and configuration items is filled. You could also look at it as part of a change. So trying to change in requirements or moving the data forward, or look at impact analysis of what those changes might be. And do that not just within the realm of your mechanical and the PLM, but also within other types of environments across requirements or software and ECAD and other types of environments there. So let's get to our story. So we've got a Mars rover, and within this Mars rover, and that's actually sitting next to me here, there are multiple components within different domains. We want to show that within OpenCLM. We've got the data from those components within the systems that are for requirements, for the product data management, for the simulation data management, and the software. And we know that through this analysis that the Mars rover itself needs an update. So we've seen that experiments, when we're doing testing on it or an analysis, have shown that there is an issue with the Mars rover maybe climbing or going through rough terrain and being able to move around the different terrains. So we're going to examine that data within OpenCLM. We're going to then propose from there what might need to be updated in order to help that and change that progress or process in order to have a Mars rover that's more efficient and more effective off-road. So we're going to jump into our OpenCLM presentation now and the interface. So starting within OpenCLM, you see the projects there in the middle. On the left-hand side, there were tasks, and then you see some information about it on the right. The left, where you see the tree view, is what we call it, is actually a view of a template that you're then extending as part of your process in order to include different types of milestones, configuration items, lists of data that you need to have. And then from there, you can also traverse that to the middle, to the graph view. Now, within the graph view, you can see these configuration items and their status. You can understand through the relationships between these different items what the dependencies are. And so this is important when we're looking at changing from maybe additional requirements or maybe adding some changes for mechanical design to it. We can, look at that in context of engineering or manufacturing changes as well. And then also software changes that you're going to see here. And adding requirements maybe for moving up and down in rough terrain and developing a more robust chassis and carriage system around that. So any one of these independent configuration items then can be related and linked to external systems. That link then can be used to propagate some attributes back as well. So when you're clicking on that relationship then goes and lets you open that within the client of that external system. In the first case, we might have seen a JIRA requirement or a JIRA issue, but now we're looking also within Windchill to the mechanical CAD that's developed in Creo of the Mars rover itself. So with all that together, we understand a little bit about the challenge, what those dependencies might be. We look at the carriage here and the assembly there that is then going to maybe need to be modified in order to handle a little bit rougher terrain. We see the tilt sensor that represents an electrical component that might need to be updated as well in order to handle that terrain. And then other requirements that are around that. So requirements for updating software, for updating hardware, and defining that. We, within CodeBeamer, have our software defined so that we can develop and build that. And, we need to investigate a new software change release as well as requirements for handling the different terrain and being able to move out and navigate that. Again, going back into Jira, new requirements for the rough terrain that are within there. So with that, we understand what change processes are going to be needed, and we can go ahead and process those changes within CodeBeamer, within Jira to update the requirements, and within Windchill to update the mechanical CAD. All this impact analysis has been developed as part of OpenCLM and as part of that product that then we can use in order to understand that a little bit more effectively. So with that, we're going to move on and introduce a little bit of OpenPDM, which is another integration platform that enables the exchange of data between any of these different systems. We know that from OpenCLM, we have done the dependency trace and impact analysis. We understand that we need two things. We need to process a change, really, but we need to do a modification of the chassis within the mechanical CAD. We also need to update the software for the tilt sensor and then publish that. So within OpenCLM, understanding those dependencies led us to this change. We have requirements that are hosted within Jira, our requirements management system. We've got software and issue tracking within our ALM system, CodeBeamer, and we've got Windchill as the host for our Creo data that's within Windchill, but also developed by a partner. And so as part of this, in the future, being that we're not design responsible for that data, we're not just going to exchange that data internally within our organization, but send that data also to a partner so that partner can then change it. So across this change and across the domain, we understand that there are going to be implications within the requirements, within the software, and also within the mechanical components of the change itself. And we need a mechanism that's going to be able to then propagate that change across those different systems. We can do that with OpenPDM. So as OpenCLM is linking the data and giving us that impact analysis, the core exchange of that data, so bringing it from one system to another and being able to create these multi-system data synchronization workflows is something that OpenPDM really specializes in. So you see that here within the digital thread that the OpenCLM has created. We understand that there's a need for this change and can then synchronize that data maybe across the product lifecycle again, meaning from requirements to mechanical to ERP or beyond, but then also kind of the other direction across domains when there needs to be a change that happens within the product itself. OpenPDM has a wide variety of standard engagement levels here. The one that we're demonstrating today is OpenPDM Integrate. And with that, you can really bring together any number of different systems and create processes around that integration to enable the data exchange to fit what your business needs are. So it's very flexible, and we'll show you how to create one of those processes in a little bit that will take data from one point and then publish that, export it, map it, and push it and import it into another system. OpenPDM is also used for migration with OpenPDM Migrate. And we use some other tools there, including an ETL-style type migration with our migration toolkit that includes source and target databases, high-performance export and import scenarios, and mapping in order to try and get the data effectively moved over. This could also, transform CAD or do other types of processes in the middle, combine data from multiple sources and things like that. We do specialize in this type of multi-vendor interoperability and can handle those situations very well and do quite a bit of that business in the United States as well. We also have OpenPDM Ship, and this includes shipbuilding CAD connectors that are specifically tailored in order to interchange data from the ship design and the ship CAD, bring that out, and then integrate it into your PLM environment. So to support those types of bidirectional exchanges. A wide variety of connectors as well, including the different domains that we're talking about already, with PLM kind of being the foundation at the bottom. We partner with these different organizations that provide then also the connectors, so the Dassaults and the Siemens and the PTCs and SAPs, Oracles of the world, that then enable us to bring you commercial support for these connectors through the specific APIs. On the bottom, you see the standard, market-leading PLM vendors. On the right-hand side, you'll see ALM, including the Codebeamer, Integrity, and Polarian, as well as some MBSE with Cameo and Teamwork Cloud. And then there's a spot for your ALM system, but you'll also see a spot for your PLM system or your other system. There's a capability with OpenPDM in order to bring your legacy system or a system that's not supported today through our product into the platform by implementing, what the interface of the connector is to the backend. So we can then also use that, plug that into OpenPDM, and then make that system a OpenPDM supported platform and allow you to use that really with all the other connectors that are commercially off the shelf. Other connectors for IoT and ERP, and then interfaces on the left-hand side. So we are PROSTEP, so we have a nice step toolkit for generating data. That's not just geometric data, but data around all types of product, like it could be bill of materials and configuration, stemming from that ISO 10303, kind of lineage with the AP214 being kind of a PROSTEP legacy, but moving on to AP242 with more modern step approaches, and then also talking about digital packaging in general. We have web services, and this is important to PROSTEP. All of our products have a prefix of open to them. And we pride ourselves in enabling the customers in order to use those products as good as then we would do internally. So where you have that web services adapter, you can then use the RESTful interface of any of these different connectors. They're very well documented. They've got a nice implementation within the connector for Swagger documentation. You can test them out and then process things that way. And we also have an OSLC provider, which enables you to then make any of these other connected systems OSLC compatible. So if you've got an OSLC consumer, a lot of ALM systems do this, then you can federate that data through those interfaces to one of the other systems that isn't natively supported by OSLC. OpenPDM can enable that. So as part of our example that we're working through right now with the Mars rover, we see a demand for this information, right? The demand could be that we're processing the change in the case of the Mars rover, or it could be that we're exchanging data across domains or across the product lifecycle. We need that information to be made available, and we don't want to do this manually with somebody kind of replicating data from one side to another. So we use OpenPDM in the middle. OpenPDM works on this concept of a trigger where you prod, I guess, the OpenPDM process server, and you trigger it to make an exchange of data. With that trigger, you send some relevant information about what needs to be exchanged. That might be a change identifier, the assembly identifier, something like that, depending on what the data is. You can then, behind the scenes, after that trigger is created, a process is instantiated within the OpenPDM process server that then pulls the data out of the source connector, does the mapping internally, and then pushes the data into the target connector. And so really kind of doing that pull, transform, and then push type of methodology. In this case, with the next movie, we're going to be demonstrating the OpenPDM process server and a creation of the change as part of this exchange. So we're starting within the Camunda modeler. We use Camunda. It's a BPMN compliant workflow engine. And we use Camunda in order to instantiate these processes initially in the modeler and then publish those to the server so that then they can be run. And then every instance of those processes is then recorded that way. You see that this is a standard template and starting point. We've got a swim lane for the export. We've got a swim lane for the mapping and transformation, and a swim lane for import. So from there, we can drag and drop and start a sub-process. We're going to define this as just an export and name it as the export change. We have a predefined configurable export strategy that you can use with any of the different connectors that will take a look at what that root node is and then kind of traverse the data structure and the relationships underneath it. So we're going to use that. It's our business object export structure query. Go ahead and work through and define some of the variables that you would need in order to store that data, to define what that top level node would be. In this case, maybe a change identifier or other identifiers, right? If you need revisions or other types of primary keys in order to process the data. From there, we're going to extend this a little bit then too to mapping and create a mapping block that enables the transformation. OpenPDM is based on microservices, so there are actually other services that handle things like mapping or trying to transform the data from one format to another. And then also an import block in order to define what that import would be into the other systems. In this case, we're just running through and kind of showing you the implementation of one of those processes. But we're going to do this maybe across multiple systems for the change definition. So that would include change data in a multi-domain type of environment. It's making sure that requirements are adjusted, making sure that mechanical CAD is adjusted, and the software is adjusted as well. So we're going to finish up filling out some definitions here. And we see the flow. And you'll see that in the beginning, there's a protocol for starting. There's also reporting in the end, and then an error block in the middle so that you can then handle those processes in the case that there's an issue. And you can publish it and test it on the server after you've created it and see it running there as well. So with that, in the architecture overall, we've seen from our our OpenCLM investigation that there's cross-domain impacts that happen with this change. We can pull that change information from those change system and then use OpenPDM in order to process that, and then concurrently publish that data, that change information to those different systems and relate the specified, subsystem data to those changes. That will then enable the one who's working within any of those individual systems in order to do their job effectively within the system that they're working in. What we want to do is avoid where people are searching within Jira in order to find the requirement, or they want to look within Codebeamer to find some implementation of code where they're really just looking for doing mechanical changes. We bring the data to them. They can then use that data and do their job more effectively within that single environment. That has an advantage then also of less licensing overall. So there's good business reasons in order to do that as well. To utilize the system capabilities that are built into the primary tool and not have to deploy and train and maintain those tools across multiple users. OpenPDM Integrate and kind of the foundation to that is its orchestration layer that is based on the Camunda technology and Camunda server. Within there, you define really all the business logic that needs to happen within a process. So the connectors, as long as they're ones that we support commercially off the shelf, you install, and you should be able to use those in order to export and import data without any modification. The modification comes right here in the orchestration layer, and then maybe in the mapping engine as well, and providing what that logic is in order to move the data back and forth. We start again with a trigger. Triggers could be done manually. We really trend to kind of stay away from what those are. We want things to be more automated and really behind the scenes. So that could be plugged into a workflow. It could be a change workflow in a release process. Could be done chronologically, where I want to synchronize whole platform overnight. Could be that there's an external input that's provided, like a file or an email, or just another REST service. This trigger is also available as kind of just a web service event within the process server. We have our OpenPDM connectors, and really that kind of is the power of OpenPDM, is the way that we neutralize data from any of these individual connectors into the process server to make that data more efficient and more easy to work with. So in this case, Jira, Codebeamer, and Windchill connectors. We support a wide variety of other connectors as well, 3DX and Team Center, and more than is on that slide. And provide a mapping service where you can go and deploy your mapping in multiple different formats. It could be like an XSLT mapping or programmatic mapping. We have a wide range of different monitoring tools. Every instance that's run of the synchronization processes that you define have all the protocols and logs associated with them that you would want to see. And notification services and other integration services, depending on what your needs are. I think there's in total maybe 15 different microservices around OpenPDM, many of them shown on there, but some other services that are available as well. And with that, we're going to go and take a look at the process server and some of the processes that have been running there. So we've got one that's actually currently running. We see that that's successful after we refresh it. We can look into not just the template of the process, but that instance of the process. Where it's green, you see that's been completed successfully. That step has been successful, and that process is run through. In some cases, if there's an issue, an administrator can use this interface as well in order to handle that issue. And that might be at the bottom where you see that there's an error. There was a step that didn't go through as part of this process. We see that flagged in red. And you can go ahead and take an action from there as well in order to restart at the current step or clone the process and rerun it or do other types of actions depending on what your needs are. So with that, we're going to continue our Mars rover story. So we've started with we started with OpenCLM and defining what the digital thread is. We understood what the impact analysis of the change would be in a kind of a multi-domain environment. We synchronized that change with OpenPDM across those different systems. And now we're going to leverage our OpenDXM GlobalX product in order to synchronize data from Windchill to our design responsible partner who's going to make the update to the CAD data and then bring that data back. So the data is housed right now within Windchill. That Creo data needs to be exported and packaged and then sent to the design responsible partner in a secure way using our OpenDXM GlobalX. We're going to automate that process with our Windchill plugin, turn that data back around, and then the design responsible partner after the update can then bring that data back into Windchill also using OpenDXM GlobalX. At its core, the product is a managed file transfer product, right? But at PROSTEP, we are deep interoperability and engineering integration, consulting and solutions. So the focus is really on how to do that more effectively within those types of systems. So with a managed file transfer product, first and foremost, security is important. So we've done a lot of strong encryption in order to make sure that it's the most secure transfer that is possible. We penetration test the software regularly, can do identity integration. We have a lot of flexibility. Also important within managed file transfer is that you make it as easy as possible to enable the users in order to use the easiest possible path to exchange data. So if you have a portal and a practice that's difficult for them to use, they're just not going to use it. But by enabling a wide variety of different clients and enabling it to have a scalable global architecture that can be used, in the cloud or on-prem or distributed across the world with remote vaults and file sharing, that all enables usage for that. Of course, reporting and these types of transactions is very important. And keeping audit trails and making sure that we can set the right security policies for that. And then back to the PROSTEP experience. So being that we are deep-seated into engineering interoperability, understand PLM and PDM integration very effectively, and how to process the CAD data. We are quality certified as well with ISO 9001 and 27001. So with our OpenDXM GlobalX product, we're going to use one of the PDM integrations within Windchill in our Mars rover example in order to exchange the data to the design responsible partner. That has really three components to it. So the first component is the client plugin. You want the user to be within the system that they're using. So in this case, it's Windchill, and you don't want them to leave Windchill effectively in order to do their job. So they start within Windchill with a client plugin that enables them from within the Windchill interface in order to select the type of data, create a package, and then from there, we go into the second part, which is our direct integration service. So really that has two components. It has a wizard component where you can select the different recipient that you would want to send the data, what the action is around that data that's going to be transferred. And then also it has connector components to it as well that then enable the export and import of that data, both kind of on a data level with metadata, but as well as CAD. And we have specialized CAD interfaces that we call controllers for that. And the third component is a data exchange tool, and that is the MFT, OpenDXM GlobalX secure data exchange that enables you to share that data outside and make sure that we've got the right type of access control and authorization and security around that tool. So with the client, we support commercially off-the-shelf 3DX, Windchill, Teamcenter, and SAP integrations. Similarly, with the connectors and the back end that power that interchange of data, as well as the CAD controllers that are specific for a system and a CAD kind of pairing. So in this case, it could be J-Link with the Creo API for Windchill, but also XPDM adapters for 3DX, or the TCIC controller for Teamcenter and CATIA, or other examples. And then OpenDXM GlobalX as the managed file transfer. Internally, within this process, so when you're exporting data, we also enable you to do some neat things with it. You can pull the data down, you can transform it using some of our tools that we've built in order to make some neutral formats. We can also build in a third-party translator in case that there's some best practice you want to follow already in order to get a different format than one we support as well. And then do quality check, do analysis of those files, understand what you're sending out or what you're receiving with that type of analysis. So in the case that you want to deliver data to your OEM, you know that you need to have certain attributes set for that data. It needs to have the right format, the right start parts, whatever that might be for CAD. Then we can ensure that quality before it goes out the door to make sure that you're hitting all of those criteria, and do that with our processing. So we're going to demonstrate two different processes here with our OpenDXM GlobalX integration for Windchill. We're going to show an export process that's going to bring the data from within Windchill once you've defined it, and send that data after it's been packaged to the recipient. And then after that, the recipient is going to do their job to update the data and bring that data then back into and import it from GlobalX, OpenDXM GlobalX, back into Windchill. So the process looks a little bit like this, where you're starting within the Windchill interface, you create that export collection, define what data needs to go in there. That then gets sent to a wizard, and you'll see this in the demonstration where we show what the action is, what the recipient is, so who they're intending to send it to, and then do some filtration of the data if you want to adjust it. And then you click go, and behind the scenes, the processing happens where the data will then be pulled out of Windchill through the right API. So in this case, if it's Creo data, we would use the export functionality of like a Creo export controller, as well as our Windchill connector in order to pull that data out effectively, do any transformation that you need to, which in this case, we're not doing it. We're sending them native data. But quality checks and analysis, package that up. Once that's all zipped up and secure, we then send an email out to the recipient. The recipient knows that that package is waiting for them. They can go ahead and authenticate back into your OpenDXM GlobalX environment and then download the content that's made available. So let's run through that process right now within Windchill. So we've got our Mars rover assembly here, and from there we can then highlight the content. We have a problem again with the instability of the chassis and the carriage components there. So we're going to take that carriage and we're going to send that to our supplier through our OpenDXM GlobalX product, and then enable them in order to work with the data and send it back. So within here, we can create a collection. We're going to gather the data that we need to, and then send that through GlobalX. We're creating a folder right now. Within the folder, you can specify, kind of the description of that. And really, this is a concept of a collector, and this is done also within the other systems that we integrate to with our OpenDXM GlobalX PDM adapters. So within the collector, we're gathering all the data sets, and then we can process it by sending it through. That opens up our wizard dialog. That's that middle dialog there. We select the action we want to take with the data. We select the recipient, who is already a predetermined user within the system. So we already have an authenticated user that we're going to send it to. We don't want to arbitrarily send the data out. So we select Susan as our intended recipient. We make sure that we have the right data that's associated with it. We can inform additional people as well. So send in a mail that this data has been sent out in case that there's additional people that need to be included. With that, we can look through the structure. We know the files that are going to be associated with that. And then we can filter files if need be. So if you collected things that maybe you don't want to send, or you want to understand exactly what is being sent, then you can do that there through that interface. This is where you click go and it's done. So that is the complete process on your end. At that point in time, really the magic happens behind the scenes where the connectors and the controllers are pulling the data out, processing the data, and then pushing the data in. So the second part to this is Susan, who is our design responsible partner, is going to then authenticate against the OpenDXM portal. So she got an email that had a link that said there's something new to download. She needs to put in her two-factor authentication that's been provided for her. She needs to accept the terms of use. And we can, configure, some of what the properties are of all these things as well within our MFT application. And then she's logged in. She has an inbox that says she's got a new file set that needs to be downloaded. She goes and looks at that and then can display it, look through the list of the files, and then go ahead and download that just simply by clicking the button. When you click the download button, you'll see that a transfer has been initiated on the left-hand side. Many times it's pretty quick depending on the files. OpenDXM GlobalX is capable of sending super huge files as well. So not very much limited by size. And then when she gets that data package, it's zipped up for her. She's got a protocol that shows what the internal data files that have been sent are, as well as the files themselves. She can then save those out into her own directory and then open that data up in Creo. And you see that when she does that, she has the original carriage assembly that was exported as part of the process is available to her in Creo. Then she can do her job by doing the modifications and meeting the requirements of being able to handle rougher terrain that we wanted to meet as part of our example story. So opening this up in Creo, and she takes a look at it, and then she can modify it from there. Yeah. So moving on with our OpenDXM GlobalX supplier collaboration story. She's going to modify that data because she's our design responsible partner, and she wants to be able to then send that back. OpenDXM GlobalX has a wide variety of different applications that are associated with that. With the base module, you get some really interesting applications for handling just general managed file transfer. And this is important in making the product easy because when you make that product easy to use, you're going to get better adoption for the product, and you're going to plug those security holes that you might have as well, and sending your data and making sure that your IP is okay. So it comes with Outlook integration off the shelf. This will route any file that's sent through Outlook to OpenDXM GlobalX to make sure that you have an authenticated user that's downloading it. You have a Windows Explorer that introduces Dropbox-like functionality where a user can just drag and drop a file into a folder and then it will route that also to be exchanged through the OpenDXM GlobalX. A right click on a file and then a send to, and this is the one I personally use the most. It's very easy. You can just right click and you've got a dialog where you can click send to and process data that way, as well as the traditional method of data exchange that external suppliers who don't have GlobalX have access to, and that's the web browser. So you don't need a license specifically as an external supplier or any other agreement. You can use the OpenDXM GlobalX product that the OEM is using, that's sending over, and they provide that portal and that UI in order for you to authenticate and download from. It's fairly simple to use. It's pretty easy to onboard people. Like I said, you don't need anything external besides a web browser in order to manage that. And you can integrate with the customer IDP if you'd like to. There's also a lot of transactional data that's stored in the back end for security reasons, understanding who authenticated at what time to download what data, and that's all available to an administrator, as well as KPIs of the system itself. So, understanding what the throughput might be of any of the different systems or total data that's stored within the system, things like that. Interesting component to this is that workflow that enables you to do the export and the translation and quality check and enable the work on the CAD data behind the scenes. This is we call our BPF, our batch processing framework. We use this for both OpenDXM GlobalX as well as OpenPDM. And the case is that OpenPDM needs to synchronize data and as part of that synchronization process, maybe do an intermediate translation. So maybe generating a viewable file or something like that you can use within the other system. We can use our BPF framework for that as well. So this enables you to scale up effectively, run these translations in parallel, and maintain those workflow processes more efficiently. And do some load balancing and performance scalability. Sometimes in handling this type of data, performance is an issue, so being able to scale up more efficiently is very important. And then finally, we're going to look at our PDM import capability with OpenDXM GlobalX. So this is the second component to that, where you're starting from external vendor and Susan has done her changes and then she wants to bring that data back into the OEM environment. So from there, she's going to start within the web portal. She's going to upload the changed data. That's a Creo changed data. The system then, once it's been uploaded to the correct web space, is going to do an evaluation of that data, understand, where things have changed, and then where they might be need to be, created new or updated or revised, or maybe removed from the bill of materials, something like that. That analysis could be done directly on the CAD file, or could be done through another independent, like XML file that's associated with the package. And then from there, we can show graphically from our import wizard what those decisions are that are being made as part of that import prognosis. Or we could have it automated if you already have the predetermined logic with that partner. You know that you're going to get this type of data. You've done the quality analysis on it as part of this import workflow. Then you can then automate the whole process and import it. So we're going to take a look at this, and Susan's going to use our OpenDXM GlobalX interface. She's going to reply. So the system does, through reply, also know that what was sent out and can take some special consideration there. Repackage the data that's been modified from there, create a message as part of that, saying that, hey, I've completed the work. I've got a new carriage assembly that I want to then upload back into Windchill, and then click go. And again, her job is effectively done here, and the system is going to take care of the rest. So behind the scenes, that's going to transfer the data. Once that transfer is complete, then it's going to be processing the data, doing the analysis of the Creo data behind the scenes again, understanding, what's been updated, what hasn't, checking against the Windchill system to see what exists there in order to do that type of comparison. So once that has been done, and Susan has sent that back to Richard, the import collection is created within the Windchill environment. So Richard always works really within Windchill. He sees that data is made available there, can take a look at and maybe some of the protocol of when it was sent, and then can go through the process of importing that data into Windchill and look at that in kind of the thorough investigation, not automatically doing it, but using the methodology that requires the wizard in order to pull that data in. He selects that package, opens up the import dialog. He needs to define the container that's going to go into because it's Windchill, and depending on the system, you might have some special considerations. And then can take a look and see if it's been modified or unchanged, and then go ahead and process that data. And then behind the scenes, where it's been modified, the connector will commit a new iteration in Windchill of that Creo data and update that assembly there. And with that, it's all been completed and the import is effectively finished. So from there, I kind of want to, maybe step back a little bit and talk through the processes that Windchill is also then taking. So there, we're going to complete what that change is as part of our Mars story and make sure that that's resolved. And then, as part of the import process that we're taking from Windchill, make sure that all of this dependencies within the changes is handled. Yeah. So we're going to go ahead and take a look at the change. The Mars rover mechanical update has been complete. We're going to resolve that here by changing the status. And that completes effectively the work that needs to get done in order to update our Mars rover. So from there, then we can take a look again at our GlobalX process and what happens really in the background of that import. We're analyzing the CAD data. We're detecting where it needs to be created new or updated or revised or deleted or removed from the bill of materials. In some cases, we can create kind of placeholder parts or physical products or item revisions or whatever you might have in order to store that data and then effectively perform the import of the CAD data itself and link that data there. So with all of that completed, our Mars rover story is complete effectively. We've resolved the change within Windchill. We've taken a look at the domain and environments within the requirements, within the mechanical and Windchill and within Codebeamer. And we understand the dependencies between those. And we can go ahead and now take a look back within OpenCLM. And then from OpenCLM, do an evaluation and show that this has been completed. So looking at that development and the dependencies, we have an updated chassis component that's been published as part of what that change is. And the development has been completed there. And then with that published development, our story is effectively complete. And we also have a relationship linking back to the updated carriage assembly, so that's shown there. Yeah. And building that digital thread. So that completes our OpenCLM Mars rover story. And you've seen with OpenCLM, the initial impact analysis again. With OpenPDM, the synchronization of the change. That could be changed from the requirements or from the software, from the mechanical. And with OpenDXM GlobalX, the exchange of that data automated from a partner who's design responsible back to Windchill as well to kind of process data and provide the interoperability that you need. So with that, we're going to jump in and change a little bit direction and talk about, I think, our roadmap.
Absolutely, Brian. Thank you very, very much. That has already been a very, very nice overview over the digital continuity as well as in companies, but also the supply chain. And as he has said, we're jumping a little bit now topic-wise, and we'd like to look at the roadmap of the further development of the product. So, Brian, I'd say let's continue.
All right, thank you. So we're going to start with OpenCLM and talk about the current capabilities and then also the future capabilities, and then do that as well for OpenPDM and OpenDXM GlobalX. So the current release of OpenCLM is release 1.2, and it supports, like you've shown here, the impact analysis type use cases. It imports some standards for import and export of simulation data that's been packaged there, as well as SysML for that analysis. And then you can plan baselines as part of this release. With a milestone, you can automate the creation of a baseline. Within OpenCLM, a baseline will enable you to kind of take a moment of time within that configuration structure, within a specific package, so that you understand where you are, really. There's been a lot of refinement within OpenCLM and the user interface, including a more effective graph view as well, and more maturity with the project dashboard. And then we've also included the ability with OpenCLM to utilize every OpenPDM adapter or connector as an adapter. So that puzzle piece that you saw earlier of all those different systems is available for you to then connect through in OpenCLM. Some future capabilities that we're working with include using OpenCLM as a cloud service and expanding the roles and the rights management and the configuration of those roles and rights management. The graph-centric UI, so a move towards a more functional and a better flow within the user experience. Comparison of the different baseline versions and also comparison of configuration items that will enable you to see what's changed between baselines, which is super important. When you're trying to reference things in the past, see what's been modified. We're also giving a migration assistant to try and link data more effectively. A link assistant, to enable you to use things in more of a batch process. So when you're trying to bring in assembly data, be able to link that data that might be underneath. Make the OpenPDM connectors a little bit more configurable so that you can use different types if your organization has got special attributes and types, enabling a more configurable mapping for each of those adapters. And then also improving the query capability to let you filter down to maybe just some set of data that you would want to see within that graph view. So expanding some of those capabilities. And this is all coming with release 2 of OpenCLM. So OpenPDM, been a significant work with OpenPDM over the last 2 years, and this is kind of a retrospective. But you'll see that with Windchill and 3DX and Teamcenter and SAP, we continue our support for those with every major and minor release effectively of those systems. We're publishing new connectors. We're also publishing connectors for other systems, like we have a 3D Experience RESTful connector that came out a couple of years ago. but then move towards the 3DX public cloud from there. We've got a OSLC provider that can enable you to use any of these systems as an OSLC federated type interface. A Jira, Git connectors, Cameo Teamwork Cloud connector, Primavera, Polarian connectors, as well as some others, Codebeamer, Arena RESTful connector. And moving forward, you'll see here that there's been, I guess, a little bit of a different swim lane here. There's some new connectors that are in development today for SAP and the SAP OData REST interface, as well as helping with the public cloud of SAP and HANA Cloud. But then you'll see at the bottom of those swim lanes there as well, important new developments with OpenPDM. So we're moving and being able to host OpenPDM as integration as a service. So that's going to be a well-defined use case that then couples two different systems together, like Arena and Jira is one of the first ones, but then we're going to be publishing more of those. We're also going to be providing data as a service. So this is effectively a cloud-based connector that enables you to then, query into the system and get data out or put data into the system as a data service. And then also an integration platform as a service. So bridging those data as a service connectors with the logical workflow that goes in the middle and also the configured mapping of what those processes are. So exciting because we're moving more into the cloud as these environments are more and more cloud hosted and moving towards that direction. So some of the initial integration as a service capabilities is coming with the Arena system that's starting right now, that's in production, the Arena Jira integration, but then also with Dynamics 365, S/4HANA Cloud, and SAP Business by Design as well in the future. These are also coming for the 3DX public cloud, enabling integration between 3DX Cloud and SAP Windchill and Teamcenter as well that are going to be available in the future. And there's also things in OpenPDM as well that are going to be defined in the future. And if we see that there needs to be new development, we'll go ahead and execute that in order to build new connectors, as we always have. So with the integration platform as a service, the architecture is in the cloud. It looks like this, where you've got the different components of OpenPDM, our connectors, and the configuration of those done within the cloud, providing data as a service. And then in the middle, we have our OpenPDM integration platform, providing the integration platform as a service. And that includes the process as well as the mapping of the data. With that, we are developing a new support portal for PROSTEP products when they've been hosted, and also other customers that can use this in the future in order to provide information and support for what those products are. Finally, let's take a look at the OpenDXM GlobalX roadmap. So we have a major release every year with GlobalX 9.3 in 21, 9.4 within 22. With the OpenDXM GlobalX integration, you see a transition here within 2022 also that's interesting, where you have release 9, and that's going to then correlate to the alignment of the GlobalX backend connectors to use the OpenPDM connectors. So that's important as well. We also had a patch for our legacy OpenDXM system with 6.7 in the past. So some neat features that are out with GlobalX 9.4. We've got a gallery view. This is enabling you then to use either an image file that you provide or processing the data in order to generate an image file so that image is then captured within the OpenDXM GlobalX interface. We also have new administrative features so that you can do internal approval processes, improve the task monitoring, and then also manage some of the import specifications and do some filtering and some other types of features there. Big push is kind of to move towards a more streamlined approach with GlobalX PDM integration as well. And this is based, like I said, on OpenPDM 9. But including wizards and expanding the capability for a more end-to-end type approach for data synchronization. So the export and packaging, the transformation of that data if it's required, the import definitions, handling those different edge conditions that might come in the import process itself. So we're really refining that and making that better in the future as well as looking at performance overall. So we've been supporting more effective file transfers in being able to distribute data more efficiently between remote vaults and shared bit data between different vaults, as well as database access and improving the overall performance of the system with these types of operations as well. In the future, with OpenDXM, we're going to move to 9.5 and 9.6. And we're also looking forward to introducing more batch processing framework, better scenarios, with trying to integrate with the backend, like I was talking about a little bit ago. Some client customization that you can configure within the interface, and adding to the processing and conversion, and hopefully, supporting the product overall with an increase of performance and deployment and load balancing. And then also integrating that with our PROSTEP support portal for SaaS offerings that we would have and with OpenDXM GlobalX in the future. So with that, I've concluded our review of the products, and I would appreciate maybe any questions.
Absolutely. So first of all, thank you so much. We appreciated your presentation. It was quite a bit of talking, so you deserve that sip of water. But we learned a lot from you. So thank you. And thank you for all of you out there for submitting the questions. And I actually do have quite a few for you. So I'll read them out. What connectors are actually supported in OpenCLM?
So OpenCLM uses, with that update with the 9.4 connectors, the OpenPDM connector interfaces. So all the connectors that you saw within that puzzle piece are compatible with OpenCLM. We can also use the OSLC, and OpenCLM can be an OSLC adapter and a consumer, where any OSLC-enabled system can be configured in order to work through that. And we also have a database type of connector where we could directly go into a database and configure queries in order to federate data that way as well. Yeah.
That sounds good. Thank you. I'll just move on to the next one, which reads, how does OpenPDM maintain the digital thread by copying data?
That's an interesting question. So hypothetically, maybe OpenCLM is more than tailored for maintaining that digital thread because it is linking data from the different systems. When you're copying data from one system to another, like when you're creating that change data within that Mars rover example, the data can be represented by primary keys of those systems. You can have references to those. You can even link data that might go to the other system. But it isn't the master authoritative source of truth, and it doesn't show the history, right? Where a combination of using OpenCLM and OpenPDM, we can have that digital thread being maintained with OpenCLM, as well as bring the data to the user that needs to use it with OpenPDM.
Thank you for that. And it seems like we have one last question for you, which says, does OpenDXM GlobalX require that business you're sending the data to buy the software as well?
No, it doesn't. So you can use the portal that you have, that web interface. But then also, if you do want to expand, I guess, some of the automation capabilities, you can adapt OpenDXM GlobalX at the supplier's site. And then we have things like robots and gateways, as well as PDM integrations that then enable you to bring the data in more efficiently if you'd like to.
Perfect. Those are all the questions. Thank you very, very much, Brian. You really added some value, especially for our international guests. It was really good to have you here. All the best to you. And a very warm thank you also to all of you who were joining us now. We do hope that you did profit from this session. As I've mentioned before, everything that we streamed in German this morning and everything that we will be streaming in German tomorrow will also be translated later on and be made available for you on the PROSTEP video platforms in a couple of days. So thank you very much. All the best to you. Continue great work together with PROSTEP and stay healthy and happy. Thank you.